So when we look at this paper, I want you to understand first that you really need to be able to explain how to find a hole, a vertical asymptote, a horizontal asymptote, an x-intercept, a y-intercept, the domain of range, and behavior. I want you to explain that in your own words by looking at the notes that I sent in the email. So, like to give you, for instance, for the hole, how do you find one? You simplify the problem. If something cancels out, that domain restriction is a hole. That's what I'm looking for there. So let's go over the rest of the actual problems, and I'll just give you like an overview of each one. Okay, so here is number one. When you look at number one, um, how do you find the asymptotes? Well, you're just going to connect the arrows from here to here, and you're going to connect this arrow from here to here using a horizontal line, and you just label them. So that one's at x equals 3, this one's at y equals 1. The hole is just a point, it's at 4, 6. The x-intercept is right here at -2, 0. The y-intercept is like 0, a half-ish. The domain restrictions are the hole and the vertical asymptote. You can see I put them there. And in a simple example, the range is similar, right? Beep, stop, beep, stop, beep. So I just put in the horizontal asymptote in the y part of the hole. It's not always that easy, okay? And I'll show you in the very next example. The horizontal asymptote is always the end behavior, so you can see that this is 1, these are both 1. So over here, I'm just going to focus mainly on the one thing that's different, which is the fact that there doesn't appear to be an x-intercept because we have a horizontal asymptote there. You can cross the horizontal asymptote, and some people said it was 2, 0. I'm not going to say that's wrong, but there's no evidence that it actually crossed it. You would need the back to know if there is one because you look at the numerator. And notice that again, the horizontal asymptote that we have here provides the end behavior, but what I really want to focus on in this problem is the range. Beep, stop, right? So you can't really use this set notation because what would you say? Y is such that y is a real number, but then y is what? Nothing that's negative. So the way you do that is you just say -infinity to 0. I mean, there is a way to do that, but I'm going to stick with the idea that if there is a gap, use interval notation. There's a huge gap up here. So let's take a look at this one. This one has 2 vertical asymptotes, so I make a list of them. It has a hole. It has a horizontal asymptote at 0. The x and y intercept are both right here at 0, 0. The domain is everything except for 1, 6, and 4. The range, I mean, the range has something to do with the horizontal asymptote and the hole, but you have to do the beeping. Beep, stop at -2, gap, beep until forever. Now, some students will say, shouldn't it be beep and then a hole and then beep? Well, look at this side. It just goes on forever. So it's 0 to infinity. All right. And then the end behavior, of course, is the horizontal asymptote. So over here, it's very similar. It's almost the same problem, except you do have an x and y intercept that you have to look for in here. And then also the range is all real numbers because of beep all the way through. Okay, looking at these slant problems, the best way to explain to you how to do the slant is this: if you print this out, is to get your phone out and connect that arrow to that arrow. If you are using a computer, annotate a line from here to here, and then find the y-intercept, which is 1, and then find the slope, which is up 1 over 1, up 1 over 1. So since that's y equals mx plus b, this first one right here is the b, and then the movement from point to point is the m. Let's go ahead and look at the other one. The other one, same thing, connect your arrows, start at your y-intercept, which is at 1, and then do the movement of up 1 over 2. So that one's a half x plus 1. Get out a straight edge and connect those arrows, and it makes more sense. So the differences are in this problem, this one does not have a hole anywhere. It has a vertical at -1. The x-intercept is right there on the axis. The y-intercept's right over here. The domain is everything except the vertical asymptote. The range is beep the whole way. So you could either write it as -infinity to infinity, or you could write it as y, such that y is a real number. And since I do not have a slant I don't have a horizontal asymptote, I have a slant, I have to actually look at the arrows. This is -infinity, this is infinity. Please notice that on this problem, I have a typo. I have the word horizontal, and that should say slant. So notice I crossed it out, wrote the word slant. It's just a typo. Not on the back, only on the front. So over here, very similar, but I have a hole. That hole is at 7, 5, vertical at x equals 2. The slant I already explained. The intercept is 0, 0. Remember, if you get 1, you get the other one for free. Domain is everything except 2. Range, let's take a look. beep to 0. And then some students, again, they'll say, isn't it beep to the whole and then beyond? But what if I look over here? It's just beep, so 4 to infinity. My end behavior is this arrow is going down to negative infinity, this arrow is going up to infinity. All right, let's take a look at the back. On the back, here's the most important thing I think on the entire back is how do you find the horizontals by hand? It's the only thing that kids really get confused on. Step 1, try to reduce this. It doesn't reduce, very important. After you try to reduce it, determine whether the functions have the same degree. This problem, I have a linear function divided by a linear function. So the shortcut is you just divide the coefficients. Now, if you don't understand that, you could do it the long way, which is to take the denominator and divide it into the numerator, putting a placeholder for 0, and then you'd have to go back to learning what we did in chapter 4, which is what does it take to make this become 4? And the answer to that question is we would have a 4 there. And that's where I'm sorry, a 2 there. Forgive me, I almost made a mistake, right? 2 times 2 is 4. So we would put a 2 here, and the quotient is the horizontal asymptote. Or you could just do the shortcut, 4 divided by 2. I'd learn the shortcut. Okay, so let's take a look at this one. This one, we have a linear divided by a quadratic. The shortcut for that is if you have a higher degree on the bottom, you always get 0. Here is why. If I take x squared plus x minus 6, and I divide it into this linear function, I'd have to have a placeholder of 0 here. And then guess what happens? I have to make this become this, and the way I would do that is I would have to multiply by 0, which is the horizontal asymptote. I would just learn the shortcut. Okay, the last thing that could happen is what happens if the higher has a higher degree, like in this case I have a quadratic over a linear, I would actually have to do this problem. This problem you actually have to do the long division. So I put the bottom right here, x plus 2, and then I write out this with its missing piece, the 0, and I say what does it take to make x become x squared? So what does it take to make x become x squared? Well, that's going to take an x, and then I distribute that, and I get x squared plus 2x, and subtract both terms, and then I do it again. What does it take x to become negative 2x? So I have a minus 2. That is your slant. Y is equal to x minus 2. So keep in mind, that's probably, for some reason, every year I teach this, that's the part that kids have the most trouble. All right, so now let's go over each one. I've done all the work, as you can see, so it won't take very long. So what we're going to do is we're going to start by saying, does the problem reduce? This one does not reduce, so I say no hole, or does not exist. Then I write down my domain restriction. The domain restriction that does not cross out is your vertical. We already talked about how to get the horizontal. To find the X-intercept, the shortcut is to set the numerator equal to 0. You could do it the long way and multiply the common denominators if you want, but the shortcut is set the numerator equal to 0 and solve. You get 0, 0. That immediately means that the y-intercept is 0, 0. If you did that by hand, you put 0 on the top and 0 on the bottom, giving you 0 over 1, which is 0. Kind of confusing. Some kids think that's undefined. It's actually 0. So I would just use if this is 0, 0, that's 0, 0. The domain is always known before you graph because it's just everything but the vertical asymptote. The range, I don't know until I look at the graph, and the end behavior is provided by the horizontal asymptote. So how do I make the graph? Well, what I do is I come to the graph and I put the vertical asymptote on the graph, and then I write down these 3 numbers, -3, -2, and -1. And then I write down the numbers afterwards, which would be 0, 1, and 2. And once I do that, I put them painstakingly into the original problem right here. And in the first case, I got -12 over -5, and then you just keep going. I got 12/5, 8/3, 4, 0, 4/3, and 8/5. You may use the calculator. I would do the quick check so you can see how the calculator works. I would make sure you understand that on the quick check, you're probably going to want to, in that calculator, you're going to want to put like 4 times -3 and hit enter, write that at the top. And in the bottom, as a separate problem, you're going to want to do 2 parentheses -3 plus 1, hit enter, and then put that answer on the bottom. I don't know if those calculators actually do things in fraction mode, so just keep that in mind. All right, so then I just graph those dots, and I have this divergentness at the vertical asymptote, which is sort of the point. The vertical asymptotes must diverge. All right, so what happens if we have a hole? Same thing. I first start off by simplifying this problem, and when I cross this out, that produces a hole. That hole is the domain restriction -1, and the domain restriction of -2 is my vertical asymptote. Okay, so I write that down, and at first I don't know that this is 1. I have no idea. This thing right at the beginning This thing is a question mark. I don't know what this is. So what I have to do is I have to come back and fill that in from the chart, right? So when I get to the chart and I get to -1, which is right here, that's when I can come in and say, oh, that's actually 1. But you don't know that answer until you make the chart later. All right, my vertical asymptote, as you can see earlier, is x equals -2. And my horizontal asymptote is y equals 0. And the reason is, again, top's linear, bottom is quadratic. When the bottom has a higher degree than the denominator, then my asymptote is y equals 0. All right, so then my x-intercept, I actually have no x-intercept, and the reason is you don't look at this problem. Like if you look at this, you'll think it's -1, but that's the whole. So you scratch this out and you say, I don't want to look at that. It's going to make me get it wrong. I look at this, and you end up getting 1 equals 0. That's nonsense. So that has no x-intercept. The y-intercept would be to plug 0 in here, which is a half. The end behavior is, of course, as we've done a million times, the end behavior is the horizontal asymptote. The domain is everything except the whole, -1 and -2. In order would be -2 and -1. And then the range we'll get from the graph. So looking at this, I'm just plugging these numbers into this function. Remember, you're plugging them into here, right? Not to anywhere else. And then I'm just doing that painstakingly, including my values I got for free. And then I graph it with my hole being an open circle. That's when I know that this hole right here is actually a 1, right? I get it from the chart. And again, why did I get a 1 there? Because when you put -1 into the chart into here, you get 1 over -1 plus 2, which is 1. So that's 1. Then you graph the graph, and the range in this case is beep, stop, beep, stop, beep, stop. So because you stop, you can use this. Same thing over here. I think I forgot to do that. Beep, stop, beep. So when you can stop and start again, that's when you can use this set notation. But when you look at these two down here, there's no set notation on this range. Beep, all real numbers. This one is beep to 0, and then gap, use a union symbol, 3 to infinity. So these are kind of long. Just keep in mind, they're actually done the same way as the ones above. They just take a little longer. You start by factoring, nothing cancels, so I have no hole. I get 2 vertical asymptotes, which become my domain restrictions. My horizontal, we already talked about it being 0, from the bottom having a higher degree than the top. To find the x-intercept, you set the numerator equal to 0, you get -1. To find the y-intercept, you put 0 in, which would be 1 over -6. You put those in your chart. Your end behavior is a horizontal asymptote. You painstakingly put all this in there. And then I want to explain something to you that's very important. When you put all this in here, you get really crazy numbers that are actually just right below the asymptote. And the reason they're so small is because the asymptote is 0. So -5/24 just means graph something slightly below 0 on below the axis. And when you come over here and you get like 5/14 and stuff like that, and 2/3, you're just graphing close to the asymptote. In the middle, when you pick these numbers, I pick symmetric values. There are 4 things in there, but I picked -1, 0, and 1 because you only have to pick 3. And then this is super important. This graph goes down because they're all negative, and this graph goes up because they're all positive, and the asymptotes must have divergentness. So that makes this a cube. Remember, in between 2 asymptotes, you can only have a cube graph or a quadratic graph. So this one, divergent, divergent, makes the middle graph cubic to diverge at those 2 asymptotes. Now over here, pretty much the same deal, other than we have a horizontal asymptote at 3 because we have a quadratic over a quadratic. The difference here is that when I fill in my chart, they're both going up. So that means that this has to be a quadratic to diverge here and diverge there. Almost the same problem. Notice I even have -1, 0, and 1. Domain is just those things. Range is the end behavior. I'm sorry, the horizontal asymptote is the end behavior. So now let's talk again about the range. This one is B the whole time. -infinity to infinity, or y is a real number, all real numbers. Here, beep, stop to 0, gap, and then beep above. Notice that has a bracket because it's in my chart. This does not because it's an asymptote. All right, last two. So we have this one looking like a chromosome, this one looking like parabolic X thing going on. How do we do it? Well, we divide the bottom into the top, as I mentioned, and we find how do you make x become x squared, giving you x. You distribute, then you have a negative 2x after you subtract, and you say, how do you make x become negative 2x? You put a negative 2 there. And students, for some reason, have the hardest time graphing this slant asymptote. It's not supposed to be hard. It's supposed to be a review of Algebra 1 concepts. So how do I graph that asymptote right there? Well, I'll tell you what, let's zoom in on it and see how I got this. All right, so what you do, again, how did I get the asymptote? I did long division, or synthetic, if you'd rather use synthetic. I did division from chapter 4. I just don't care about the remainder because remainders are for factors. I only care about the quotient. So the quotient is telling me to graph a line starting with a y-intercept of -2. So I come to -2 and I put a dot there. And then from Algebra 1, it tells me my slope is 1. So my movement, my m, is up 1 over 1. And I can do it again if I want, up 1 over 1, right? I can go back if I want, down 1, left 1. And that's my asymptote, my slant asymptote. All right, so after that, once you get over the difference of that, the vertical is just the domain restriction because I didn't have a hole. So there it is. There's my vertical asymptote. My hole, I don't have a hole, and the reason I don't have a hole is because I didn't cancel anything out. So you could say none. Notice that sometimes I say none and sometimes I say does not exist. They mean the same thing. And then my x-intercept, this is where the shortcut is so helpful. Set the top equal to 0. You get -3 and 3. Okay. The y-intercept, I put 0 in here and I got -9/2. Domain is everything except 2. The range I don't know until I graph it, and the end behavior I don't know because I don't have a horizontal, so I don't know what it is yet. So I graphed that. I graphed my vertical asymptote. I made a chart at -2, included 3 values to the left, 3 values to the right. I painstakingly put them into either this function or this function because in this case they're the same because nothing canceled. And then I got these dots here and then the dots there, giving me this chromosome looking graph and making the range all real numbers, -infinity to infinity. All right, our last problem. Now, our last problem for some students is a little intimidating because it starts out looking like a cube. But remember the first rule is pretend like you're in chapter 5.1, right? 5.1 says take that x squared out and on the bottom factor. And then you cross this out and you get a hole. That hole would be that domain restriction, the -2, and the -1 would be the vertical asymptote. You can see that right there. And at the beginning, of course, we don't know what the hole is. It's going to come from the chart. Our slant asymptote, the way I found it, I don't think, and it's just an important thing to remember, once you reduce, do not look back at this. I mean, I don't feel like dividing that horrible mess. Divide this. X plus 1 goes into x squared plus 2 placeholders. X needs to be multiplied by x to get x squared. Distribute, subtract, you get -x. X times -1 is -x, and that's my asymptote right there. I'll zoom in on that and show you how I did it in a minute. All right, my x-intercept would be set the numerator equal to 0, which would give you 0. Y-intercept would be 0 plugged in, which would be 0 over 1. Again, I just like to know if I get this, I get this for free. It's a super time saver. So the domain is everything except the whole, -2 and -1. The range I don't know until I look at the graph. The end behavior will look at the graph as well. So how did I graph that slant asymptote? Well, once I did the division, right, it tells me to graph a y-intercept at -1. So that y-intercept at -1 is right here, and then the movement or the slope tells me to again go up 1 over 1, up 1 over 1. Keep in mind, okay, that it's not always that's not always the slope. It just happens to be the slope, on the 2 problems I gave you. The slope could be 3/2. It could be up 3 over 2. All right, so then I made my chart, focused at my vertical asymptote, 3 points to the left, 3 points to the right. I also then noticed that, oh, okay, -2 gives me -4. So my hole is actually right here. And that means I'm going to go fill that value in from my chart. All right, so I make my graph here, and I put an open circle there, and then I have my intercept that I found, and I go this way. So it's kind of weird when you look at it because you only have these values, right? And that's where the concept of the asymptote is really important because it's going to go along the asymptote and through here and go down to the vertical. So when you graph it, it comes out looking like that. All right, so let's talk about the domain and range, the range and the end behavior. The end behavior is it's pointing down, so negative infinity, and then it's pointing up, so infinity. The range is beep to 4. It's an open circle, so parentheses, and then nothing, so union, and then beep to infinity, so I have a square bracket. Now, I'm not sure if I did that over here. So I think I did the range, but the end behavior is negative infinity, right? It's pointing down, and then infinity pointing up. It's not always negative infinity to infinity. Notice the very next problem, but it was also the same thing, negative infinity to infinity. It could possibly, right, be the other way around. I mean, this slant asymptote hypothetically could go this way, and then it would be going up. But anyway, I just want you to just trust the graph and understand that you don't know what the end behavior is unless you have a horizontal. So if I don't have a horizontal, I have to look. If I have a horizontal, I get it for free. I hope this helped, and I hope you study.